we can begin by just copying down what was given. And then from there, we can start to try to build. Right? We want to show that angles 1 and 2 are equal to each other. Well, if you kind of work your way backward, the only way to show angles 1 and 2 are equal is if we can show angles 3 and 4 are equal. And then we know that each of those is a part of a linear pair. And so that's kind of the progression that we'll have to take. Okay? So again, we can either interpret our given, or we can try to introduce our end state. Well, the given is that these two sides, RT and QT, are equal to each other. And there is another relationship that you can derive from that. What kind of a triangle is RTQ? It's an isosceles triangle. So what do you know about the base angles of that isosceles triangle? They're equal. So we could make the statement that angle 3 and angle 4 are equal here. And when you justify this, a lot of you have been putting definition of isosceles triangle. That's not going to work because is there any place in this proof that you identified that's an isosceles triangle? No. So you can't use that as your justification. What you can use is one of the concepts that we talked about in section 5.1 was that angles opposite equal sides are equal. And so that's the relationship. Angles opposite equal sides are equal. Okay, so you can describe the relationship if you don't have a shortcut or abbreviated acronym for it. Okay, but we can now say that angle, so we knew that these two sides were equal. We can now say that these angles are equal. We still need to introduce our element of angle 1 and 2. And there's really nothing else that we can do to interpret our givens or build from what's in here. So we need to go ahead and take this opportunity to introduce the elements of our end state. And so the only thing that we can say about those is that measure of angle 1 plus measure of angle 4 forms that straight line. It adds up to 180 degrees. Same is true between angles 2 and 3. And what kind of angles are those when you have adjacent angles that form a straight line? Those are called linear pair. So by definition of linear pair, or you could say linear pair add up to 180 degrees. And we've now introduced our two elements. And so now we have to work to make them equal to each other. Okay, the first part of that is to get them in the same equation and on opposite sides. So here we have two things. Here's two things that are equal to the same thing. Therefore, they're equal to each other. So angle 1 plus angle 4 is equivalent to angle 2 plus angle 3. And what justifies that? Two things equal to the same thing are equal to each other is transitive property or substitution. Okay, and then our final step now, we're just one step from reaching our end state, and that is to get angle 1 on one side and angle 2 on the other. We simply remove equal parts. So angle 4 is equivalent to angle 3, so we can remove that from each side, leaving angle 1 on the left and leaving angle 2 on the right. And what process eliminated those? Good, subtraction property. And so in those 5 steps, we were able to complete this proof.